Okay, this video accompanies our 1-3 mathematical literacy page in Savvas Geometry. So what they want us to do is they want us to find the distance between A, which is at -2, 3, and B, which is 4, 14, and round off to the nearest tenth, which is 1 decimal place, and then justify our steps. So one way to do this, using the Pythagorean theorem, is to plot the numbers relative to where they sit in the axis system. So A is at -2, 3, so back 2 up 3. This is around where A is. And B is at 4, 14, so it's out here at 4 and up here at 14. So I'm not drawing it to scale, but B is at 4, 14. It's a 4. And A is at -2, 3. And B is higher than A, so that's like the key idea. So what I want to do is I want to find the distance between these 2 points. That's what they want us to do. Now here's kind of a slick way you can do this with the Pythagorean theorem. A squared plus B squared is C squared. If we look at this distance here, we're going to use this as our A squared. We're going from -2 in the x direction out to +4. So we're using -2 and 4. That's a total distance of 6. So if we kind of recreate a triangle to represent that, this distance is 6. Now if we look at our difference of our y's, our y distance, we're going from 14 down to 3, which is a distance of 11. So Pythagorean theorem tells us that this distance is going to be the square root of 6 squared plus 11 squared. So 6 squared plus 11 squared is 36 plus 121, which gives us 157. So the square root of 157 is going to be the distance from A to B using the Pythagorean theorem and just kind of looking at the right triangle that's formed there. You're really finding the difference of the x's, and you're finding the difference of the y's. Again, from a -2 to 4, +4 is a distance of 6 in the x direction. And from 3 to 14 is a distance of 11 in the y direction. So 6 squared plus 11 squared, take the square root, you got it. Now, rounding-wise or estimation-wise, I know that 13 times 13 is 169. And I know that 12 times 12 is 144. This is 13 above and 12. So it's kind of halfway in between. I might guess like 12.4 if I just needed an approximate answer. But for this problem, they want us to use the distance formula. And so we're going to use the formula and pretty much do the same thing we just did there with the Pythagorean theorem. So they're finding the difference of the x's. They're doing 4 take away -2. Now 4 take away -2 is actually 4 plus 2 because the two negatives cancel, which gives you the 6, and it's going to be squared. So that's where I got our 6 squared. And the difference of the y's, if we do 3 take away 14, we get -11. If we do 14 take away 3, we get +11. That gives us the 11, and when we square it, that's basically what we got when we did 11 squared over here. And 36 and 121 comes out to be 157. The square root of 157 into 2 decimal places is 12.53. And so they rounded to 1 decimal place as 12.5. So there's our answer for the square root, or the distance between point A and point B, where they're located at those points. Notice that if you just need an approximate answer, you can come out pretty close. 12.4 is not too much different than 12.5, and I did all this pretty much without a calculator. So let's look at the problem they want us to do here. What's the distance between -5,5 and 213? Round to the nearest tenth, justify your steps. So here they're kind of leading us through this. So first off, let's see what they did up at the top. I think they're just going to write distance formula. Yeah, write the distance formula. Okay, so we looking at our coordinates. Now this is kind of another trick that you got to be, kind of consistent with. Your first coordinate's always your x. Your second coordinate's always your y. Always goes x, y. You run sideways before you jump up, down. X before y. Now, since this is the first point, a lot of times I'll put little sub numbers there. So I'll put like little 1 there, and 1 there. And I'll put a 2 there, and a 2 there. Just because this y came from point 2, this x came from point 2, this y came from point 1, this x came from point 1. And this more directly fits everything into the formula. So we want to write the distance formula. And then we want to plug the numbers in. So the way I have these labeled, my x2 is 2. I'm going to do the distance equals the square root of x2 minus x1. But now x2 is 2. And x1 is -5. So I'm going to do 2 minus -5. And again, minus a minus makes a plus. Okay, do the next part. Extend this on. So that was the difference of the x's. Here we want to do the difference of the y's. So plus y2 minus y1. Now y2 is 13. And we're minus y1. y1 is 5. And so we need to crunch these numbers and take the square root. So let's see, the distance is going to be 2, take away -5 is 2 plus 5, which is 7 squared, plus 13 take away 5, I could do plus -5, is 8 squared, and the square root of that is going to be our distance. Now, 7 squared is 49, so they did that. So this was, let's see what we do, simplify. What we did here was 7, another simplify. 49 plus 64. I'm trying to make it match what's on the side here. Got square root of that. Now 49 64 is going to be 113, I think. We get 100 and 113. Another simplify step. And by calculator, they're saying that the distance comes out to be about 10.63. We're rounded to 1 decimal place. Without using the calculator, they had it for us. We get 10.6 rounded to 1 decimal place. So that's our 1-3 mathematical literacy and vocabulary on the distance formula.